This diagram illustrates the high-speed physics of a hull breach. A 2-inch hole located just 1 foot below the waterline will admit enough seawater to fill a 55-gallon drum in exactly 42 seconds. At that velocity, the window for crew debate or internal politics disappears. The sheer speed of marine flooding and shipboard fires demands an immediate, pre-programmed response rather than a reliance on heroic improvisation. Catastrophic failures like this one forced the maritime industry to develop rigid survival frameworks. International regulations like SOLAS and the ISM code exist to replace human panic with standardized legal requirements for safety and management. Survival at sea depends on the crew's ability to execute these protocols through relentless monastic repetition, ensuring every action becomes a reflex before the crisis begins. A maritime crisis is triggered by a specific auditory signal: 7 short blasts, followed by 1 prolonged blast on the ship's general alarm bells. This alarm strips away individual decision-making, sending the crew to the stations pre-assigned on the vessel's muster list. Every crew member and passenger moves to a specific zone, ensuring full accountability in a matter of minutes. Under maritime law, the general alarm initiates this mustering process rather than the evacuation itself. It transitions the ship into a state of high readiness, keeping everyone accounted for before the master considers an order to leave. Fire remains the most universally feared threat on a commercial vessel. A ship is surrounded by salt water, yet that water cannot safely extinguish many of the chemical, oil, and electrical blazes that occur in an engine room. To contain a blaze, the crew prioritizes boundary cooling. By spraying seawater continuously across the bulkheads and decks surrounding the fire, they absorb radiant heat and physically prevent the inferno from migrating into adjacent spaces. The crew uses 2 distinct levels of breathing protection. They carry an EEBD, a compact escape hood with 15 minutes of air for rapid evacuation. For sustained firefighting, they don an SCBA, which provides up to an hour of pressurized air for operations inside the burning compartment. When a fire becomes uncontrollable, the master authorizes the CO2 total flooding system, a weapon of last resort that smothers the compartment in gas. Before activation, the crew must complete the mandatory shutdown of engine room blowers to ensure no fresh oxygen is being pumped into the space. Fighting a shipboard fire is a calculated mathematical battle. Success depends on the systematic elimination of oxygen and heat rather than simply directing water at flames. Water ingress is detected instantly through hydrostatic level sensors in the bilges. The moment water rises to a defined level, the alarm sounds simultaneously on the bridge and in the engine control room. To prevent progressive flooding, where water moves through the ship subdivision by subdivision, the bridge remotely activates the watertight doors. These hydraulic steel barriers isolate the breach and preserve the vessel's overall buoyancy. If the ship runs aground, the crew immediately sound all tanks and bilge spaces to identify breaches.
They monitor tidal shifts and seabed nature constantly, as a rising tide may offer the only window for extrication before the hull sustains terminal damage. Managing a flood is an engineering struggle to manipulate the ship's internal geometry, buying the time necessary to stabilize the hull or prepare for evacuation. When a crew member falls overboard, the emergency shifts from internal engineering to external navigational geometry. The fastest recovery method is the Anderson turn. The helm is put hard over until the ship swings 250 degrees, bringing the vessel back to the casualty while they are still in immediate visual sight. If the casualty is missing, the bridge executes the Williamson turn. The rudder is put hard over until the ship deviates 60 degrees from its original course. Shifting the rudder hard over the opposite way brings the ship onto her exact reciprocal wake. This maneuver lets the vessel traverse its original path in reverse, providing the best chance of regaining visual contact when the casualty's position is uncertain. Standardizing these maneuvers reduces the variables a bridge team must manage under pressure. By adhering to rigid mathematical tracks, the vessel narrows the search area significantly in a featureless ocean. The ultimate procedure begins only when the vessel can no longer be saved. Ship abandonment is the final tactical shift, occurring only when boundary cooling and flood containment have failed. Even in terminal conditions, the evacuation follows a strict hierarchy. No one enters a lifeboat until the master gives a direct verbal order, which is typically signaled by a continuous blast on the general alarm. Before leaving the deck, the crew dons immersion suits. These thermal protective garments feature integrated watertight seals at the wrists and neck, designed to prevent rapid body core heat loss during prolonged immersion in cold water. As the crew prepares to launch, the ship's EPIRB, or Emergency Position Indicating Radio Beacon, is activated. This device transmits location and distress data directly to international search and rescue coordinators. The final escape often utilizes a free-fall lifeboat, a reinforced capsule launched from a steep stern ramp. It drops under gravity and plunges into the water, surfacing clear of the sinking or burning parent vessel within seconds. A successful abandonment operates as an orchestrated transfer of life, moving the crew from a compromised environment into a functional survival craft through a predefined sequence of actions. This entire escalating crisis was actually a mandatory training drill. On a SOLAS-compliant vessel, these sequences are practiced monthly to ensure every crew member knows their duty by heart. The exercise ends with the crew exhausted and their gear wet, followed immediately by the work of resetting the ship's safety equipment to its fully operational state. This level of repetition is designed to override the psychological weight of panic. By training for the worst-case scenario until it becomes mechanical, the crew ensures that if the ocean ever tests them for real, they are ready to survive.